Please watch your language. Alright, here we go. Oh, the other side. Alright. We are solving absolute value inequalities. So this has the same basic technique. Once you have the absolute value isolated, you're going to rewrite it twice. One, the positive version on the left, right, and the negative version on the right. Now, the biggest difference is when you do the negative version, you're going to change the direction of the inequality. If it's less than, you're going to make it a greater than. And then you solve them separately. All right? Now, let's talk about all these special cases. If you have absolute value, make sure you have the absolute value isolated. If the absolute value is less than 0, there is no solution. And that means it could be anything. It could be like absolute value less than -5. That's less than 0. If absolute value is less than -5, it's no solution. Okay? If absolute value is greater than a negative number, absolute value greater than a negative number is all real numbers. All right. So these two are the special cases of no solution or all real numbers. The second one, or the second pair, is how the solutions go. All right, so if the absolute value is less than a positive number, you have an AND situation. An AND situation when you graph it, so your AND situation when you graph it, it looks like this. It looks like a line segment. It could be open-ended, but the point is it's going to be a line segment. If it's greater than or equal to, it's an OR situation. An OR situation looks like this, where it's opposite direction. Okay. Well, here's a big hint. If you don't remember which one it is, it's not a big deal. You just graph it. If you graph it and they run into each other, then it's this one. If you graph it and you run into each other, what I mean is, let's say you graphed it this way and the other one you graphed it this way. That means they're running into each other. They're going together. Then it's just going to be the space in between them. So you're just going to do like this. Just the space in between them. Right? And I'll give you an example in a minute. If they go in opposite direction and they don't run into each other, that's it. You're done. If they run into each other, you want to make sure you give a final answer that looks like this. I will give you an example of that in a minute. Alright? Alright. So, is it important that you know that it's an AND or? Not really. Okay? Because I'm not giving you the more sophisticated problems where you have to figure it out. Where it is important to figure it out. So we're only doing the easy problems. Okay? Alright, and then somebody pointed out this morning, wait, this was in Algebra 1. That's true. This was covered in Algebra 1. But I need to make sure you still remember how to do it. Alright. So here. So this is isolated absolute value. So you're going to rewrite it. X over 6 is greater than 1. And x over 6 less than 1. And then, whoops, it's less than -1. Sorry. So remember, you got to do a positive version and a negative version. And in the negative version, change the direction of the inequality. In the negative version, change the direction of the inequality. All right. So now, multiply by 6. That gives you x is greater than 6. Multiply by 6, you get x is less than -6. Alright, so graph this, x less than -6, open circle over -6 and you go to the left. Open circle above +6 and you go to the right. So this is going in opposite directions, that's the answer. Okay, so keep in mind there are basically 3 answers to this question. You have the x greater than 6, you have x less than -6, and the graph. The graph is considered an answer. You have to have all 3 parts in your answer. Yes, ma'am?
So the circle is always going to be open?
No. This had a less than, there was no equal to bar, so that's why it's open. Ready for B? Hello? Okay, going on to B. To be or not to be. Alright, so in example B, the absolute value is not isolated. So I got to get rid of the -9. To get rid of the -9, I divide by -9. Do you remember what happens when you divide an inequality by a negative number? Tucker.
What happens when you divide an inequality by a negative number?
Correct.
The sign switches.
That's right. So this less than becomes greater than. And that becomes greater than 4. Okay. A lot of people are skipping this step. So first period, a lot of people skip this step and messed it up. Like if you skip this step, chances are you won't realize it's a no solution or all real numbers situation. Okay? So you do not want to skip this step. It looks redundant, or you can just write it like this and then treat it like it's this version, right? So if you wrote it like this and kind of treated it like this, where it's without the absolute value, you're less likely to make a mistake. But you want this step where you have the absolute value still part of the inequality. So that's the positive version. That's a +4 less than -4. That's the negative version. Subtract 4, subtract 4. So x is greater than 0. Subtract 4, subtract 4. X is less than -8. So x greater than 0. X less than -8. I can't see. -8. So make sure you isolate the absolute value first before you decide whether it's all real numbers or no solution. So this one, you might have looked at it, oh, there's a negative number over here. But you had a negative number on the side with the absolute value that forced it to become positive. Okay? All right, C. Please let me know if I'm going too fast. Right, Tucker? You really missed Cameron, didn't you? All right, so looking at this problem, what's the first thing I'm going to do? Subtract 7. So that's going to be 8, absolute value x over 9 is greater than or equal to -8. What's the next step?
Divide by 8.
Divide by 8. So you have isolated the absolute value. This is a special case though. Which special case is it? Right? It's greater than a negative number. Absolute value greater than a negative number, so it's all real. You can put the real symbol. Okay, when you put infinity, that means there's an infinite number of solutions. So it's almost right. But this is saying anything works. Infinite means there's just infinite number of solutions. This is saying anything works.
So
Okay, so it's a little different from infinite number of solutions. Yeah.
So no matter what, when it's greater than or greater than or less than or equal to a negative number, it's always all real numbers.
No. You have to first isolate the absolute value, and it has to be greater than. Not greater than or less than. It has to be greater than. Its absolute value greater than a negative is all real numbers. If its absolute value less than a negative, it's no solution. Okay, let's talk about that then. Why is that the case? So if I take the absolute value of -3, what is that?
3.
3. 10 plus 3, 3. So can it be less than some negative number? No. So that can't happen. That's why it's no solution when it's less than a negative number.
What about if it's greater than?
If it's greater than a negative number, right? So let's say greater than 5. Well, no, I'm sorry. Greater than -5. So anything that comes out is greater than a negative number. Okay? So a weird situation is, what if it says it's greater than 0? You're lucky, we're leaving those out. Alright! Greater than 0 is kind of weird. That means it can't equal 0. I guess that really doesn't matter. Alright, let's go to D. That's why we didn't bother. Because it doesn't really matter. Alright. So this one, the absolute value is already isolated. So that's going to be, so I'm going to do a rewrite. 3x minus 6 is less than or equal to 3. And 3x minus 6 is greater than or equal to -3. Solve each one separately. Add 6, add 6. Divide by 3. Repeat the process over here. Add 6, add 6. This time I get a positive 3. Divide by 3. I get x is greater than or equal to 1. Okay. Now be careful how you graph this. Watch me graph it first before you start copying it, okay? Watch me graph it first before you start copying the graph. Alright. So, I'm doing x is less than or equal to 3. So here's 3. This is the filled circle because there's an equal to bar, and it goes in this direction, right? And then x is greater than or equal to 1. It starts over here, over 1, and it goes in the opposite direction. So this is, they're going in opposite directions, and they run into each other. Do you understand what I mean by where they run into each other?
Yeah.
Right. So the overlapping region is the answer. So this top part that's the answer.
So
Okay.
from 1 to 3.
1 to 3, that's right.
That's the answer.
That's the answer. Okay, so personally, I wish you didn't have to do this bottom part. If you can skip those 2 lines first, that'd be great. But if you don't skip those, that's fine too. Nothing wrong with that. That's just a little more work. It's not a lot more work. Okay, but the top graph is the answer. And you don't have to point it out to me. I'll just take that as the answer. My water.
Straight? No.
All right, 2 more examples. E. All right, here we go. Absolute value, -3 minus 8x. I'm going to multiply by, what is that number? 8. Multiply by 8, I get -16. Can absolute value be less than a negative number?
No.
No. So it's no solution. What symbol will I accept?
0 with the line through it.
0 with a line through.
It says so.
All right, ready for F? F. All right, so the first thing I want to get rid of is the -5. Remember, you have to isolate the absolute value first. Divide by -6.
Why you got that thing in the box?
So what?
It's like square.
Oh, that's the line for addition, and that's the absolute value sign, and that's the division bar for the -6. So it's not really a box. It's just a series of lines. Then I'm going to write the -7 plus 9x is greater than -11. If you're going to be lazy, I'm showing you how to be lazy. Like this is a normal version, right? The absolute value version without the absolute value, and that sign's positive. This is what it looks like. So you can just add 7 to both sides. So it's 9x is less than 18. X is less than 2. Add 7 to both sides. 9x is greater than -4. X is greater than -4/7. Now, this is where you can, for your own benefit, you can put this in the calculator to get a decimal. Most people have an easier time graphing decimals on a number line than they do fractions. Okay? That's perfectly okay. Fractions aren't common sense. Okay? So x less than 2, where is that? Here's 2. And less than, I'm going to the left. Yeah? I'm going to the left. I'm going to draw a little small one because I'm expecting them to go in opposite directions. Well, they always go in opposite directions. I expect them to run into each other.
If they don't, is it no solution?
No, then it'll just be both of them.
What's
Yeah.
the 7 underneath the -4?
What is the 7 underneath -4?
Like why?
Because I made a mistake. What should it be? 9. I make mistakes. All right, so that's -4/9. So where is -4/9?
Is it
Where's negative 49? It's between what two numbers? 0 and negative 1. So I'm going to put it here. Right? And then greater than that, it goes to the right. So here, there's my answer. A really small line thing. Alright, now I'm giving you a chance to work on these independently. I'll come around and help you individually. Therein ends the lesson.